And that map now contains actionable steps. Let's formalize that into the practical debugging checklist for you, the learner.
Okay. When that curl command fails, avoid the panic button. Follow these steps sequentially. Number 1.
Step 1, Layer 1, outside ingress check. Start with that synthetic test we gave you, curl-vk resolve domain.443.lbip https.domain-path. This eliminates all external dependencies. If that fails, check your ingress controller logs for 404s or TLS errors.
Step 2.
Step 2. Layer 2, service endpoints check. Verify kubectl get SBC endpoint slices. Is the endpoint list for your service empty? If it is, fix the label selector mismatch. Is the service type correct?
Step 3. If layer 2 looks good.
Step 3. Layer 3, kube proxy kernel rules check. Check the health of the kube proxy pod on the relevant node. Then shell into the node and verify the kernel's reality. iptables-tnot-eln or IPv6-eln. Are the pod IPs listed in there up to date and pointing to live destinations? Step 4. Step 4. Layer 4, CNI status check. Verify the health and status of your CNI daemon set. If you're using a routed network, check your BGP peers. For overlay networks, double-check your MTU settings and VTP health.
And step 5, the final destination.
Step 5, Layer 5, pod application check. Once you've confirmed connectivity to the node, execute inside the pod. Run ssdal-oltnp to confirm the application is bound to 0.0.0 and listening on the correct port. Then check the application logs for any internal errors or resource starvation.
And what if all 5 of those steps show green?
Only then should you assume a security layer problem. Scrutinize your network policy objects and perform those targeted TCP dump captures both inside and outside the pod to confirm the packet isn't being silently dropped by a firewall rule somewhere.
That's a structured, repeatable methodology that turns a frustrating mystery into a logical diagnosis process. That was a complete trace. We realized that Kubernetes networking isn't magically complex, but it is systematically modular. We've identified the 5 specific problems that are solved by the 5 specific layers, from the ingress controller's L7 rules all the way down to the final application socket binding.
The required mental shift for mastery is to view your network traffic not as some abstract concept, but as an observable physical entity that you can track across discrete physical and virtual boundaries. To really solidify this knowledge, we have a challenge for you, the learner. Go beyond just observing and start intentionally manipulating the system.
Okay, we challenge you to practice 3 crucial mental and technical tasks.
First, map a new service completely. Choose a service in your own environment, trace its path, and for each of the 5 layers we discussed, document the specific command output or log artifact that confirms that layer is functioning correctly for that specific request. Write it down.
Second, reproduce a failure mode. Don't just read about it. Set up a small lab environment, a mini kube or K3's cluster will do, and intentionally simulate that kube proxy crash. You can do it by setting its memory limits dangerously low. Watch the kernel rules freeze, and then observe the silent traffic drops that are confined only to that single node.
This transforms the dependency lesson from a story into a practical, felt experience.
And finally,
measure. Deploy a simple echo service using 3 different layer 3 and 4 configurations. One using standard iptables, one using IPVS, and if you're feeling ambitious, one utilizing an eBPF-based CNI like Cilium. Then, use load testing tools to measure the difference in latency histograms and CPU utilization across all 3 setups.
because only by measuring those real-world performance trade-offs will you truly understand why choosing IPVS over iptables matters at scale.
That deep interaction with the system mapping, reproducing, and measuring is the fastest route to achieving true mental mastery over Kubernetes networking.
Thank you for joining us on this deep dive.
We hope that the next time you see a connection timeout, you won't feel confusion, but a clear, structured list of 5 places to look.
Until next time, keep digging deep.